All right, so today we're going to start talking about some more root algebra, right? Should still be some review for you. We're going to talk about solving equations, and by the time we're done with all of this, you should be able to solve any of these types of equations: one-step, two-step, multi-step, variables on both sides, all that kind of stuff. My guess is you're going to remember how to do most of this. It just needs to be needs to be a bit of a refresher for you. So, some vocabulary. First of all, an equation. An equation is a mathematical sentence that uses an equal sign. Different than an expression. An expression is a mathematical phrase. It's not quite a whole problem, where an equation is a whole problem. It's a full sentence, however you want to look at it. And we treat them differently, expressions and equations, and so we need to understand the difference there. When we solve equations, right, we'll talk about solving equations. We are actually creating equivalent equations. Equivalent equations are equations that have the same solution, right? And so an equation like 2x minus 15 equals 45, right? Remember that a solution is any number that you can plug in for the x to make this sentence true, to make this equation true. And so if I asked you right now, what's the solution? You wouldn't be able to see it, right? But if I gave you this equation and asked you what the solution was, what can I plug in for x to make this sentence true? Hopefully you'd tell me 30. Well, this equation and this equation are equivalent. They have the same solution. 30 is also the solution for this equation. If I plug in 30 for x, 2 times 30 is 60. 60 minus 15 is 45. And so it's just, we're trying to create an equivalent equation where the solution is easier to see. And it's easier to see down here, right? That's the idea. Now, we create equivalent equations by isolating the variable. Isolating the variable. What we're talking about is getting the variable on one side of the equal sign with a coefficient of 1. Okay? Excuse me. A coefficient of 1, not a coefficient of 0. And we'll talk about that as well. We isolate variables by using inverse operations. Inverse operations undo each other, right? The inverse operation of addition is subtraction. The inverse operation of multiplication is division, right? And that's what we're going to use to help us isolate a variable. All right, difference between an expression and an equation. This is an expression, right? There's no equal sign. We're not solving for anything. And we've done this, we did this leading up to the last test, but we just simplify this, right? We follow through in our order of operations, where we're going to distribute the negative 8 first, because there's nothing to do inside the parentheses. When we do, we get 3x minus 16x minus 24. And then we combine our like terms and get negative 13x, right? Notice that we're not doing any inverse operations here, right? We didn't add 16x to the 3x because we're not solving equations. We're not trying to move anything across equal signs or anything like that. We just straight up combine our like terms in as much as we can, and then we stop when we can't do any more, right? So there we go. That's a simplified expression. Same thing here, right? We don't need to do any inverse operations because we're just talking about simplifying an expression, combining like terms here, adding those guys and getting x, adding those guys and getting negative 2. So x minus 2. Okay? But when it comes time to solve for a variable, when it comes time to isolate a variable, that's where we want to start bringing in our inverse operations. We're going to want to undo addition and subtraction first, and then undo multiplication and division. It's kind of backwards from our order of operations, PEMDAS. That's because we're unraveling some of that simplifying. Okay? All right, so for example, this g plus 2 equals negative 8. You probably remember that in order to isolate the g, we're going to subtract 2, right? We want to undo the addition. And we're subtracting 2, so we're doing the inverse operations here because there's an equal sign. This is an equation. Okay? And we're and since we want to subtract 2 on the left side, we to isolate the g, it means we have to subtract 2 from the right side of that equal sign to keep the equation balanced. Now when we do this, 2 minus 2, those don't cancel. That actually gives you 0. And it's important for us to remember that. Negative 8 minus 2 is negative 10. It's important for us to remember that when we do that, the reason why we cross the 2 minus 2 out and we don't write anything down is because they add to 0, and g plus 0 is just g. So we get down to g equals negative 10. Right? Again, if I'm asking you for a solution, the solution is negative 10. Because if I plug negative 10 in for g, this would give me a true sentence, a true statement. So, since this is an equivalent equation to that, I should be able to plug in negative 10 for g and make this a true sentence also. And it turns out that's absolutely true. Okay? Now, same idea here, right? We want to try to isolate the variable. Right now, that is not subtracting 6 from x. So we do not want to add 6 to both sides. Instead, we're multiplying the negative 6. And so we want to divide both sides by negative 6. Negative 6 divided by negative 6 is 1. Remember our definition of isolating, right? It's trying to get the variable by itself with a coefficient of 1. We've now done that. This becomes negative 4.5, or negative 9/2. Okay? Since the variable has a coefficient of 1, we don't typically write it. And so this is our solution. X is equal to negative 4.5. Okay? And same thing here. We still want to get the p isolated with a coefficient of 1. Right? Fraction bar means divide, so I need to undo the division by multiplication. And so we're going to multiply both sides by 3. And these 3's will divide out because now there's a 3 in the numerator and a 3 in the denominator. They divide out to 1. And so we get 1p, and then 5 times 3 is 15. Okay? So hopefully we're remembering all of this. All right, number 4 gives us a look into having to do some multiple steps here. Right? Trying to get m by itself with a coefficient of 1. And we need to undo addition or subtraction first. And since this guy is what we're trying to get m by itself, we are subtracting it from this 10. So we need to undo, or we need to get rid of this 10 first. And so we want to subtract 10 from both sides. And again, we do that because 10 minus 10 is 0. And I'll stop writing this 0 eventually. But I want to make sure that we understand. And then 0 minus 16m is negative 16m. Right? So my point behind doing that is minus signs need to be brought down as negatives. Right? Don't forget to do that. It's very easy to do. And then, of course, from here we're going to but divide both sides by negative 16. Negative 16 divided by negative 16 is 1m. And then 160 divided by negative 16 is negative 10. And so we're there. All right? All right. We'll continue on here. Try number 5. See if you remember how to isolate x there. And stop the video, start it back up, and make sure that you're getting it correct. All right. So did you add 3 to both sides? Negative 3 plus 3 is 0. They don't cancel. And then divide both sides by 2. Right? 2 divided by 2 is 1. And that's what we want to have happen. We want the coefficient to be 1. And so we get 11 over 2. Right? All right. Next one. Again, I mentioned that there's a difference between equations and expressions, and we want to make sure that we understand that difference, right? The right side there is an expression. And we can simplify expressions before we try to solve equations. In other words, I want to treat that like an expression and just combine these like terms before I start trying to solve. Combine 5m and 2m and you get 7m. That's perfectly fine. Okay? And then we go through our process where we add 23 to both sides. And we get 7m equals 28. Divide both sides by 7. And m ends up being 4. Right? On the same side of the equal sign, we can just combine them. We can just add those like terms. But if they're on opposite side of the equal signs and we've got to move them across the equal sign, then we've got to do the inverses to move them. Okay? So try 7. Simplify that left side first. See what you come up with. Stop the video and see if you're right. Okay? So, did you combine your like terms here? 11m and negative 6m will give you 5m. Then we add 8 to both sides. Then divide both sides by 5, and we get m to be 6. So, the solution to that equation at the bottom, m equals 6, is 6. If I put 6m for m, then it would work. If you put 6n for m up here, then this would work as well. This is 66 minus 8 minus 36. 66 minus 8 is 58. 58 minus 36 is 22. Okay? And so that's a true statement as well. Check your answers. Right? Do yourself a favor and make sure that you're getting these right by plugging in and checking your answers. Okay? All right. Number 8, it's the same concept. We still want to simplify. Right? We want to distribute the negative 8 here, get negative 16x plus 8 equals 36. And then go through our process of subtracting 8. Then divide them by negative 16. And we get negative 7 over 4. Okay? Good. Hopefully all of this is coming rushing back to you. Right? Try to solve... we haven't talked about this yet. Number 9. Again, we would try to simplify each side by combining like terms, just adding like terms, right? But we can't do it like this. We can't just add those guys and get 7x because there's an equal sign here that we have to move across. This is where we're going to start collecting our variables and collecting our constants, right? We can subtract 2x from both sides here. So we're moving across the equal sign. When I do that, I want the x on one of the sides of the equal sign to add out to 0. These guys add out to 0, and so they'll go away. And these guys will add to 3x, and that's how we effectively move the x's over to one side. Then we're going to subtract 2. Divide by 3, and x equals 4, right? So 4 should be our solution. We should be able to plug in 4 for x in the bottom equation and 4 for x in the top equation. I mean this guy, and get true statements. Okay? All right. Try 10. Stop the video, start it back up, and see how you do. All right. Did you distribute the 2 and distribute the 3 first, get 10x minus 2 and 3x plus 33. And then we've got to collect the x's. So I had to zero out, I had to subtract 3x from both sides, so that gave me 0. We end up with 7x minus 2 equals 33. And then we go from add to 2 both sides, divide both sides by 7, and x ends up being 5. Okay? All right. Number 11 seems to be a little bit simpler. You can really collect your variables however you want. You can move whichever one you want, or zero out whichever one you want. I'm going to add the 2y here and add the 2y here. That way the coefficient on y stays positive, 5y minus 2. Okay? And then we add 2. then divide by 5, and y is 2. Okay? Again, remembering that this bottom equation, y equals 2, is equivalent to this top equation up here. They have the same solution. So 2 will work in the bottom guy. It's also going to work in the top guy. All right? All right. Number 12. We'll take a look at number 12 together really quick. Hopefully you recognize that you've got to distribute this 2 first. Right? Now, we're going to collect the x's. So subtract 10x from both sides so that we can zero them out from one side. 10x minus 10x is 0. So we get 12 over here. 10x minus 10x is 0. And so we get 12 over here. Now that's weird. We don't have any x's left. And that's okay. That happens. Sometimes the x's will completely add out to 0 and we won't have any more x's. And that's okay. All right? So what does that mean, though? Right? We have 12 equals 12. Well, question is, does 12 equal 12? And the answer is yes, of course it does. Right? 12 always equals 12. And since there's no x in this equivalent equation, that's still an equation that's true. 12 equals 12. Then, since there's no x in there, it means we can put anything in we want to for x up in this top guy, and it would still make that sentence true. The left side would still equal the right side, no matter what we put in for x. So we can pick any number we want, and that will work. If that's the case, then any number is going to be a solution. In other words, all real numbers are our solution now. Or, as some have said, you can just say infinitely many solutions. That's the same thing. Okay? Now, compare and contrast that to this, right? The next one, where we combine these like terms. And then when we subtract 9m from both sides to zero them out from one side, we get negative 4 equals 5. Negative 4 does not equal 5. Notice that there's no m here. Negative 4 will never equal 5, which means that there is no way that I could ever plug anything in for m that would make that sentence true. Okay? So since that's the case, there's nothing I can plug in for m to make that true. That means that there's no solution to this. Okay? All right. Now, the idea behind an algebraic proof. This is a 2-column proof. We're going to argue our way from the beginning of, we're going to argue our way from one equation down to the equivalent equation. And when we argue, we want to provide sufficient support, right? We want to give good reasons for doing what we're doing. And in algebra, the reasons are all simply algebraic properties, right? Well, first off, we can't start a problem until we've been given an equation. So we have this equation here, and that was given to us, so we're always going to make this given. Okay? The left-hand side, we're just going to solve the equation the way that we would solve any other equation, right? Like we're going to subtract 7 here. But we're going to show each step in detail, right? Since we're subtracting 7 from both sides, there actually is a property that says that you can subtract 7 from both sides of an equation and it still be, and you create an equivalent equation. That property is simply called the subtraction property. Subtraction property of equality, but we shorten it to subtraction property. Okay? What would come next is us simplifying, right? Or us combining like terms here and here. 7 minus 7 is 0, and then 15 minus 7 is 8, so we get 2x equals 8. So this is, like I said, we're combining like terms, so we can just call it that, combine like terms. Or we can just say that we're simplifying. So simplify. Okay? You're going to see me use simplify more than combine like terms. So I'm going to cross out combine like terms and just keep using simplify. Now, the next step in solving our equation is dividing both sides by 2. So you need to rewrite the equation showing that we're dividing by 2. Since we're dividing into both sides of the equation, we're using the division property. Easy enough. And then when we actually divide it out, x ends up being 4, and we're simplifying again. Right? And so now we're done. We've solved, and we've given reasons for doing all of our steps. Okay? So the bottom line is we're using properties, and we're naming the properties, whatever it is that we're doing. Right? So, like in the next one, right? We've been given this equation, so we want this to be given. And then we would subtract 5 from both sides to solve. Since we're subtracting, we'd call this the subtraction property. Oh, by the way, if we were adding something to both sides, we would call this the addition property. Okay? So now we're going to simplify. We get 24 equals negative 3x. And then we would divide 3 into both sides. Since we're dividing, we're using the division property. If we were to multiply something into both sides, we would call it the multiplication property. And so x ends up being negative 8. We get that because we're simplifying. Okay? All right. Last but not least, we've got this guy, and obviously we've been given this equation, so given's going to be our first reason. But pay attention to the fact that we can actually simplify before we do anything else. We can combine like terms there and get negative 3x minus 2 equals 1. And this is us simplifying. So just again, the left-hand side, solve the equation the way that you would solve it. The right-hand side, we're going to fill in the reasons based on whatever it is that we're doing in each step. Right? So obviously next we're going to add 2 to both sides. We want to show that. This is the addition property. We get negative 3x equals 3. And we get that when we simplify. Then we're going to divide both sides by negative 3. And this is with the division property. And so we get x equals negative 1, and we get that when we simplify. Okay, so that's how we do our 2-column proofs. All right, that's it. Homework's out in Canvas. Make sure you get that done by next time.